Hello, everyone. We're going to talk about our last type of transformation today, and that is called a dilation. So, today we're going to talk about dilations. Okay, so we're going to explore them, we're going to identify them, we're going to figure out this idea called a scale factor, and then talk about the different points that are needed, like the center of dilation, and then how the points will actually move from that point. Okay, this is a review on all the other transformations we talked about. Okay, remember when you have a transformation, it can be a translation, which is a slide. It could be a rotation, which is a turn, or it could be a reflection, which is a flip. And what those do is they change the location, which is the translation. That's the slide orientation, the way it is, or its actual shape. And this one is called the dilation, when it actually changes the actual shape of it. When we have an original, we call it the pre-image, and we don't have the prime notation, and the image is the new guy. It has prime notations. And if you remember, the statement tells us lots of things. It tells us how things match up. So G matches with G prime and H with H prime and so on. In this particular example we're looking at, it looks like a flip or a reflection. So let's practice that. A little review here. So look at this. Okay, we have one without tick marks and one with prime marks or tick marks. So it says that MNO maps the triangle MNO. So this guy became this guy. So what would angle M correspond to? Well, M would have to match up with M prime. So that would be M prime. In the image of side NO, N to O would be N prime to O prime, and we can put a segment bar on top. Okay, and this one looks like it's a rotation. It was a turn. Okay, these are the words you're going to need to know. A dilation is actually like a size change of a figure, and that's going to be a new one. It's the only one that does not leave what we call the congruent figures. It is not going to be congruent when you change the size. It's an enlargement, means to make something bigger. A reduction makes something smaller. And the scale factor is going to be, it's a ratio, which means a fraction of, how do I want to say this? It's the ratio of sides, we'll say side lengths. And the way we'll do that is we'll put, it is the image length over the pre-image length, and we will actually end up simplifying that. And similar figures are figures that are the same shape, but it's a different size. So it looks like a bigger or smaller version of what you start with. So those are the vocab. And here's an example of a dilation like we talked about. It's a size change. So this would be the pre-image, and this will be the image, even though there's no markings. And you can see that it's an enlargement. It gets bigger. Okay. They are not the same shape exactly. They look similar because they're different size. So we call those similar. They're similar because it's the same looking shape, but it's a different size. And similar figures have some properties that we will talk about later. So how can you tell if it's a dilation or not? It will happen if it's not about flipping, it's about changing the size. So it's not about flipping, it's not about turning, and it's not about keeping it the same. It's about changing the size. So if it's a dilation, you know that it was a size change. And this was also a pre-image to this. This is an enlargement. So you can have an enlargement that will get bigger, or you can have a reduction that will get smaller. Okay. Always go to what's original to the new guy to tell what's happening. So make sure I didn't skip one here. Okay. So this idea of similar figures. This thing about similar figures is very important. The angles of similar figure are congruent still. The angles have to match up, but the sides are not. It says they're proportional corresponding sides. What that means is if I put the image over the pre-image, I'm going to get the same fraction. So on this example, I have a 6 that would go with the 3. 6 over 3, that equals 2. That's that idea called a scale factor. Well, this will also have to be the same, 6 over 3, which is 2. Um, and the image of a dilation will always end up being similar when you're done. Now, this was an example of a square, and obviously all the square sides are equal and all the angles are equal. But sometimes if I can go back to this triangle we were looking at here, let's look at this one. Let's say that this was 5 and this was 10. Then this would have to be 5 and this would have to be 10. But if this was, let's say, 8, what would this have to be? It'd have to be 16 because these angles are matching. But if it's going to be similar, um, then when you put the new guy over the old guy, it has to give you the same fraction. And 16 over 8 is 2, 10 over 5 is 2, and so on. Now, it doesn't always have to be 2, but that was just an easy one for us to talk about. So we have an example here. Triangle ABC is dilated to get to here. First of all, is that an enlargement or a reduction? It's getting smaller, so that is a reduction. Okay, so what will the length of A prime, B prime have to be? Well, we put the new guy over the old guy. So this 5 matches with the 10. And if you put 5 over 10, you get 1/2. So that means all the sides have to be that way. So then whatever question mark is over 8 has to be 1/2 as well. So what could that be? Well, that means that what's happening from the 10 to the 5, it divided by 2. So from 8 to get to here, I'll have to divide by 2, and that will be 4. So what do you guys think that BC would have to be? B prime, C prime, excuse me. You would also divide by 2, and that will be 3. Because when you put the new over the old, you have to get the same fraction. That is what it means for the sides to be in proportional. Now, what is the scale factor? The scale factor is that number. So on the last one, we put the new guy over the old guy and we got 1/2. So the scale factor is 1/2. On the one where it gets bigger, it was 2 over 1. And they were related, but what happens is if it's bigger than 1, that means it's going to be an enlargement happened. If it was less than 1, it's a reduction. So on this one, it is an enlargement. It's getting bigger. But this time, if you can see, I did not times it by 2. You cannot use addition. That's very important. You cannot use addition. This is all about multiplication. So when we figure out what the scale factor is, we put the new guy over the old guy. So the new guy is 15. Well, what matches with the 15? That's the 10. Well, what is 15 over 10? Well, they both have a 5 in common. So that would be 3 over 2, which is the same thing as 1.5. So actually the scale factor here is 3 over 2 or 1.5. And it has to match for all of them. Guess what 9 over 6 is? Well, 9 over 6 is also 3 over 2 because it has to be, which is 1.5. And then the 12 over the 8 is also 3 over 2, which is that 1.5, which is the scale factor. And because the scale factor there is bigger than 1, you can tell it was an enlargement. So we're going to find the scale factor here. Here's the original and here's the new guy. It is a reduction, so I know it's going to be less than 1. When I'm done, the answer is going to be less than 1. So we're going to put the new guy length over the old guy. So the new guy is a 3. Well, what matches up with the 3 is a 6. Well, what fraction is that? That's 1/2. Guess what? Can I do it here too? Yep, I could have used the 6 and the 12 because no matter what I use, I have to get the scale factor being the same, and that will be 1/2. And if I wanted to change from one to the other, I could take 6 times 1/2 to get to 3, or 12 times 1/2 to get to 6. So when you have a dilation, there's also a center, and it's kind of trickier to see, and some of you will like this more than others. It's kind of an artsy thing, but the way the scale factors work is this. If I know how far away this is, let's say that it's 4 away. If the scale factor was 3, then I'll take the 4 times 3, and my new A prime will be 12 away. So 4, 8, 12. Maybe A prime would end up being here, because then that would be 12 away. And that's what this is saying. If you know what this distance is from the original to the center, if you multiply by the scale factor, that's where the new piece will be. And again, if this was 4, if the scale factor was 1/2, when you take 4 times 1/2, that is actually 2, and that would be a reduction, and the reduction would be actually closer to the center. So let's practice. In this diagram, from the center to P is 2. And then to the new guy, it's 8. So what could the scale factor be? Well, we have to figure that out. 2 times the scale factor is equal to 8. So how do you get the scale factor? Well, you can divide both sides by 2, and the scale factor had to be 4. So 4 was a scale factor because 2 times 4 is 8. Now, you can actually make construct dilations, which is kind of cool. So let's say you have this original guy, A, B, C. What you do is once you know where the center is, you draw these rays through all the points. We don't pretend this one's not here yet. And then you will measure this distance. Let's say this one's 6. Then you will multiply it by the scale factor. Let's say that it was 1.5 again. Let's say the scale factor was 1.5, or 3 over 2. If I take 6 times 3 over 2, or 6 times 1.5, I actually get 9 for my new piece. So then this distance, 6 all the way to here, would be 9, and that's where A prime is. I would do the same thing for B and B prime. Whatever measurement this is, I would take it times 1.5 to get the new guy. Whatever distance from here to C is, I would take it times 1.5 to get the new guy. You connect the dots, and that's how it gets enlarged. It could also work if it was a reduction. It would just get closer to the center instead of farther away. So let's actually try it. We have a segment. I'm going to dilate it. The scale factor is 2. Now, I don't have a ruler. They already drew the rays for me, but we kind of got to measure here, okay? So let's say, how long do you think that is? Well, whatever it is, I need to take that distance times 2. So if that's there, then where's my new guy going to be? It looks like maybe about here. Let's say that's B prime. And you can count the dots between if you want. 1, 2, 3, 4, 5 in between. 1, 2, 3, 4, 5 in between. That's pretty good. Okay? Because I took that distance times 2 to get the new one. So what's this distance? It's like 1, 2, 3. Take that times 2 and it'll be like 6. 1, 2, 3, maybe 4, 5, 6. So maybe that is right about here. That's where A prime is. Now I can connect the dots with my straight edge, and that is an enlargement. It's actually twice as large as the original one if I was using a ruler for sure, but I was kind of eyeballing it, so it's not perfect. How about this one? This time, we're going to say the scale factor is 1/2, which means half the distance. So if 0 to C is this far, where does it look like it's halfway? Maybe right about here. Maybe that's where the new C is. B is trickier because it has that point that goes in between it. But if I'm halfway, I feel like B, I might need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like 6 away maybe. That'd be about halfway. So let's put B prime right here. And where would A prime be? Well, halfway for A prime looks about like this. And that's just a guess. You connect it, and it's half the size. That is the reduction this time. It got closer to the center, and it got smaller. Okay, so on this one, what do we know? Take a look. The original has no primes. The new guy has primes. Is it an enlargement or a reduction? Well, it definitely got bigger. It's an enlargement. What would the scale factor be? There's two ways you could tell. You could use the 3 and the 6 here, or you could say this is 4, 4 times what gets me to 8, and the scale factor is 2, or you could have done the 6 over 3, which is 2 over 1. And where would the center of that dilation be? It's 0, and we know that because it comes out of those rays all meet up there. Okay, here are some facts. Scale factors are the things that reduce or enlarge it. If it's less than 1, it's reduction. If it's bigger than 1, it's an enlargement. And I actually forgot the T there, sorry. And if it equals to 1, it can just be the same thing. They're not truly dilations. It's basically just a congruent figure. And if it was equal to 0, there would be no dilation. It would not be K. So it has to be a number like less than 1 and bigger than 0 or greater than 1. So what is the range for something that is reduced? Well, if it's reduced, it can't be 0. So let's say between 0, and it has to be less than 1. It can't be 0 and it can't be 1, but between those values. And if it's an enlargement, it just has to be bigger than 1. Can't be 1, just be bigger than 1. And if it was 1, it would be a congruent figure, the exact same shape. Okay. This is basically everything up to what we talked about. A dilation changes the size. And if you look here, this was an enlargement. If this is 2 and the whole thing is 4, that was a double. And you could tell that it doubled in size, which is why the scale factor is 2. The scale factor tells how much larger or smaller it is, and we use multiplication, not addition. Oh, this is from my old one. I never took that off. And we're all done. These are all old stuff. I got to delete that. Okay, guys, I will talk to you later.